he asked me this, I realized probably, within a week's time, I didn't really know how to answer this question. It kind of grew as I learned the data pipelines better. And so, when you're kind of going middle of a project and you're trying to figure out how to best monitor a system, it's pretty interesting. You may think you know, but you learn a few things along the way. Um, so wanted to give you guys kind of the lay of the land. So my story started like this. We had we had a lot of different services. So just to kind of take you through from beginning to end, we had a lot of different data sources, some APIs, some databases, some data files that were being shared from different partners of ours. And our compute or our transformation logic, as we took things from raw data sources to more and more rich data sets that our BI team could use to report on. This is Databricks. These icons down here are Databricks, which is kind of our compute engine for running transformations on the raw data as it goes through these different layers. For those of you familiar with modern data architecture, this is typically what you see in the industry they call the medallion architecture. So, from bronze to silver to gold, there's, the data architects that we work with usually are the ones who determine what transformations should be done in bronze as opposed to silver, and finally in the gold layer. Gold meaning like that is the curated data for BI, data scientists, analysts, anybody that's wanting to use this data that we have enriched in our data lake. I guess I didn't mention data lake either. We do have underneath all these databases, there is Azure Data Lake storage as well, and to orchestrate all of the different jobs, all of the different transformation steps as data passes through each of these layers, we have Azure Data Factory calling different notebooks, passing parameters, triggering different pipelines at different times. Also an important component that I'll talk a little bit about Azure Data Factory is the monitor within Azure Data Factory. It has its own monitor that you can use to see what's going on, what's failing, maybe rerun a job that has failed. I'll talk a little bit about that, or maybe a lot about that, because that's where I started, really, to try to understand all of this that was going on. Azure Data Factory was my best friend at the beginning. So yeah, what could go wrong here? What could go wrong? And I have to give credit to my one of my solution architects. He did a great job putting this diagram together. So what could go wrong? Basically, everything. Everything could go wrong. Okay. Data, you don't receive data for whatever reason. Somebody who is supposed to drop a file didn't drop the file, and now we have a problem because we were expecting a file and it's not there. API failures. Now, this is something I learned here recently in the last couple of years is APIs, you better count on them failing because cloud technology, that's how it is. You think whether it's Amazon, whether it's Google, whether it's Microsoft, I don't care what vendor you use, there are going to be failures for whatever reason. Sometimes vendors will update their technology stacks. They'll migrate data centers. They have outages. I mean, just recently we had a very big outage that affected anybody who was on the Microsoft platform. I forget what the name of the outage was called, but it was all over the news. So things fail all the time, and especially with APIs. Unannounced cloud updates. I love these. So we all of a sudden jobs are taking longer or jobs start failing, and we didn't change anything. We didn't change any code, or we're sleeping at night and we're getting text messages on our phones that the latest data is not coming in. Why? We find out later that it's because one of our cloud systems did an update, and they didn't really do a good job of letting us know that they were going to do that update ahead of time. Also popular in the cloud world is compute failures. In modern data architecture, you hear a lot about the separation of compute versus storage, and it's brilliant. It's a great way to operate today in today's world with data. But compute, you are depending on systems of virtual machines that are out there in the cloud that are working together, and depending on the size of the compute that you're using, or depending upon the languages that you might be using for transformations, could be Python, could be Scala, could be whatever. Compute can and will fail. So you have to, it's helpful to have tools to kind of guide you through what could be the potential problem. Are we making smart use of our compute resources? Do we have enough compute resources, for all our environments, dev, UAT, production, whatever. Even BI reporting. Sometimes the BI reporting needs its own compute, or should have its own compute. Breaking changes, you could screw up the code, deploy something, and your deployment pipelines that you didn't anticipate breaking, those break. Daylight savings, that's an interesting story. We had daylight savings actually mess up one of our data pipelines, a very important one. So again, anything that can fail will fail. Software development makes high use of CI/CD, or DevOps source control. Sometimes people mess things up, and you have to if they deploy something and they deploy it at 1 p.m., your job runs at 5 p.m. And fails and keeps failing, but you don't get notified right away. What do you have to see to tell you that, hey, this thing has been failing since 5 o'clock yesterday? So anyway, a lot of things can go wrong. So kind of like I said, walking into this architecture that was already in place, already working, already BI reports on top of it, I recognized really early on that I needed a data ops team. Kind of like an operations team, but I needed a data ops team that was solely focused on things like triaging the issues, because we had, just because there's issues on the system doesn't mean that everybody has to stop what they're doing until the issues are clear. Otherwise, it's a very inefficient system, especially when you have big teams of people working 5, 6, 7, 8. In my case, I think we have about 15 people working on this data platform right now that I'm on. So very important to have a team of people, because that kind of are there around the clock for things that could happen, and be able to resolve or identify and then resolve the issues. This team also, I formed it because I wanted to develop tools. I wanted to develop a monitor or monitoring tools that would help us see what the heck was going on. And I'll show you here in a second our first iteration, second iteration, third iteration of our monitoring tool, as we learned more and more how to monitor it better. This team also I made responsible for communicating these issues openly, without any fear of getting reprimanded or whatever. Hey, we have an issue. We're looking into it. We'll be back to you with an ETA. That's it, right? Then hour or two later, give an update on where we're at. That this team would be responsible for that kind of thing. And then also, I totally separated the communication of this team so that as we were working out issues, we weren't disturbing other people's projects. They don't need to know that, like, out of all the data sources, we have a problem with this one. Maybe it only impacts a subset of the users. So, we alerted the team, but we know that we're not impacting everybody. So, I formulated a way for the communications to happen within just the data ops team so that we could use these tools to triage the issues, identify the issues, the root cause of the issues, and then ultimately squash them. So, um, I already covered the architecture, right? And I already told you guys that one of the monitors that was my best friend was the ADF monitor. But it turns out that Azure has a ton of monitoring built into it right out of the box. There's Azure Monitor, which behind Azure Monitor inside of Azure, there's what I'll talk about in a little bit that it's collecting logs. So you spin up um, any resource in Azure, there's a log for that. Somebody logs into Azure, into the Azure portal, there's a log for that. So Azure Monitor is kind of like the central hub of all of Azure for all your monitoring needs. Now we were using Databricks too. Databricks has its own monitor. And then, by nature of the beast, right, being that we have all this data and it's sitting in tables that we can query using SQL, another tool was just writing SQL. When we all wrote SQL, me and the other 5 to 6 data engineers on my team, that's a lot of what we used to do in the early days before we had these monitoring tools. Was just write a bunch of SQL queries, and we still do to this day. We still do to this day sometimes to triage issues and figure out what's going on. Nothing wrong with that, but you could only guess at, like, if you had a team of 6 and everybody's writing SQL queries, it can get pretty crazy pretty fast. We also built custom QA frameworks. While these do serve a purpose, I'm not going to talk so much about them because there's a lot of flavors of these, and in the end, I think what I'm going to show you is, without getting into like monitoring of the data at like the I don't know. There's a time and place where you would test for things like, does a column have nulls? Does it have blanks? Are there duplicates? Referential integrity? All those types of, kind of more DBA type of checks are good. They're really good, and people have built some very sophisticated QA frameworks. But what I'm going to talk to you guys more about in this story is more like practical application. Like, hey, a new customer came in, but he's not completely set up in our data. Let's fire an alert. Or, hey, some of the data has been stale for days. Why don't we know about that? I'm going to talk about those types of things, those types of problems, rather than, get at the column level type of checks that are helpful again, but just that they serve a different purpose when you're designing a database or building a database from scratch. So all of those monitoring tools were great for a little while. As I was trying to understand the lay of the land and I was trying to monitor the systems and get familiar with the pipelines, it was great, but it wasn't enough. I needed something better. I needed, and I tried to explain this when I was trying to address the holy grail question. What's the holy grail of data monitoring? I was trying to explain that I needed a heartbeat on the system, and I had to explain this concept to more than one person. Even my data architects, is that I needed a way to be able to see, like, just like a patient that walks into the ER. The first thing they do is they hook you up to this machine to see, are your oxygen levels good? Is your heart good? Is your pulse good? Is everything good? You're breathing good and everything. And I didn't have that. I had no way to tell if our system was good. I just had this monitor, this ADF monitor that had, you know, millions of records of pipeline runs. And yeah, I could tell what failed, but there was, again, thousands, maybe millions of records of failures. And I had no way of telling, are we good? Are we bad? Are we getting better? Are we getting worse? So a lot of questions that I wanted to be able or these questions here, like what is not performing, right? Very important to answer that when you're dealing with a lot of different pipelines, a lot of different data sources. Where are we in trouble? So a failure happens midway through your data pipelines. What didn't run? What did run? Should we run everything again? What should we tackle first, second, etc.? Does the failure imply that we need to have a code change? Does it mean that we have to look at the compute? Does it mean that we have to maybe address a permissions issue? Maybe somebody changed the password. Thank you. Who's the point of contact, right? Over time, that's kind of a question that you'll answer as you get to know who's responsible for the data sources or who was the last person that developed certain pipelines. And then this is an important one. Are we executing what we said we are executing? So I'll talk through a very practical example in my case where we had a job that had to run every 20 minutes. And that's what we said. We said, yep, this job runs every 20 minutes. And I had nothing to prove that our job was running every 20 minutes. So I needed something. I needed something to be able to say that our job executed every 20 minutes and what it was supposed to do actually happened. I needed something custom, but I needed something fast. So as I was looking around, I also was trying to weigh in on some tool that I could use to analyze, that I could use to shape the data, that I could use to kind of create my own monitor tool. Because the part of Fabric that I'm very familiar with is Power BI. So I was looking for something like that. So in comes Log Workspace Analytics. Log Workspace Analytics is the kind of the storage engine behind Azure Monitor. Everything in Azure that can be monitored, VMs, Azure Data Lake Storage, Azure Data Factory, Logic apps, everything, app services, it can all those logs can be dumped into Log Workspace Analytics. So it turns out, whoops, sorry. So it turns out, and I owe all the credit in the world to Prakash Rajamanikam on my team for figuring out how to connect to this thing in Power BI. Turned out it wasn't that hard, but he figured out how to do it based on him working in the analyzing the logs. This screenshot here is a picture of what it looks like to query a log workspace analytics workspace, a log workspace analytics workspace. I think I got that wrong, but anyway, it supports this language called Kusto query language, which is very handy for filtering, not just maybe your specific a specific status that you need, but also the date range of how much data you want to bring in or how much data you want to analyze. It's very little cost. Out of the box, you get 30 days worth of logs. If you want more than that, then you get charged on the data that you store and the ingress to this tool. And I've already talked about that all the Azure services can feed into it. So a couple tips. on analyzing these logs because we ran into these things as we were trying to do this. You want to narrow the number of days depending on how much data volume you have in your logs. We for us on our project, our sweet spot was 13 days. It started off as 18 days, but slowly we started adding more and more pipelines. So we had to cut back more and more because what happens is when log Workspace Analytics cuts you off or throttles your egress, then you don't get all the logs, and it may look like you're missing pipelines. So just be careful of that. The other thing that in our case we found is that we only needed 2 statuses of ADF pipeline runs. We didn't, and what I mean by that is in log Workspace Analytics, it will log every state of your pipeline. It'll log when it starts, it'll log when it's in progress, it'll log if it succeeds, if it fails, if it's canceled, and I think even if it's rerun. In my case, or in our case, I should say, we just needed a status of what succeeded and what failed. We started there. We could have got more fancy with what was in progress, but we figure, or I figure at least, if I was interested in what was actually running, I'd actually use the ADF monitor. I'd just go into the ADF monitor and see it in real time versus trying to refresh something into Power BI. And that's actually probably a tip I missed here. Something about log Workspace Analytics too is there's some latency. So there's about 15-minute latency between, in particular, I guess I should caveat this, that all the tips I'm talking about are working with log Workspace Analytics as it pertains to ADF, Azure Data Factory. Other services, you may see different behaviors, but maybe some of this will help you as if you guys are looking into monitoring your data lake storage or some other Azure resource. Also, in the diagnostic settings in Azure Data Factory, you have to change the diagnostic setting. There's a setting that you have to set to resource specific so that you can get access to this ADF pipeline run. And there's another good object called ADF activity run. So ADF pipeline run, if you guys are more familiar with Azure Data Factory, you build pipelines, but within the pipelines you can have multiple activities. So ADF pipeline runs are the parent object, and then inside of a pipeline you have multiple activities. So that's where you could have both tables at your disposal. And there's a link here. We'll publish this out so that you guys can access these things. I could probably bring this up later if you guys want to see, but okay. So hooked up log Workspace Analytics to Power BI, ingested it, started to try to make sense of the data, and this was our first iteration. Right away, it was a very scary finding. A lot of failures. A lot of pipeline failures in the last 14 days of operation. So, and I try to do this so that I could show the successes and the failures. And while this was interesting, there was still a lot to be improved. We added some slicers here, but still it didn't give me the answers of what was failing, where did I need to go, who do I need to contact, or what do I need to start looking at, compute, code, or something else, permissions. So and then additionally, we also tried to just list the failures in hopes that we could learn, like, okay, what is really failing and what should we be looking at? And what we found was there's just too many things to discern what is the problem. Where was the problem at which layer, which level? So I looked after we looked at the data and decided, like, this is a great first start. Great first start. We had, some failure information. Great first start, right? But in my case, and in probably some of your cases that are here today, we have a very big pattern where we have parent pipelines, parent ADF pipelines, and child ADF pipelines. And sometimes we have, or in my case, in this architecture that I was stepping into, we had pipelines that would call pipelines that would call pipelines, and on and on and on. I think down to maybe 10 levels. We had that many, child pipelines calling other child pipelines and so on. So I've seen that pattern before. I've seen it. And I knew, because I had done this on other projects, that I could take that, child of a child of a child of a child and flatten it. And I knew this was key because, out of all the pipelines that I was seeing either fail or succeed, I just needed to know the top level. That's all I wanted. I just wanted to know the top level pipelines, all our top level pipelines, and that's it. I just wanted to know our top level pipelines. Are they succeeding or are they failing? And how long are they taking, right? To do this kind of thing in Power BI, there's this great function called the path function. It can take, now I immediately noticed this pattern when I saw in the ADF logs that there was a run ID and a predecessor run ID. So parent-child relationship or parent-child hierarchies is what this pattern is called. I've worked this pattern in finance. I've worked this pattern in sales and marketing. And now it's even applicable in an Azure Monitor. So very, very handy function to take what looks like this and follow the yellow brick road and turn it into this. Turn it into a nice, flattened hierarchy that then you could like search for level 1s, or maybe you're interested in level 4s, etc. Great way to handle ragged hierarchies, and it's probably the way, I think it is the way that you would handle these types of hierarchies in Power BI or tabular models, they're called, where you that's more of an analysis services. That's for analysis services, which is a different Azure service altogether. The other thing that was very handy to me, leveraging this in Power BI, and you could use this in Fabric using data flows, is if you connect directly to Log Workspace Analytics, you can expand the nested JSON objects of the ADF pipeline runs object. There's a lot of nested JSON, like the predecessor run ID, that's a nested JSON. If you're feeding parameters in your ADF pipelines, that's a nested JSON. So it's really great because if you expand the nested JSON objects in your Power Query or your data flows, then they just automatically become columns for all of the data that's in your that you're pulling from Log Workspace Analytics. The other thing that this was helpful was it helped me understand those logs. It helped me understand that I had 9 levels deep worth of pipelines. It also helped me to understand the limitations within the data, because even though there were activities that are that tied to pipelines, there were some things that I couldn't query based on the limitations of these logs. So it helped me to see what I could do and what I couldn't do. It provided me with these analytical data sets that I could just play with, that I could start playing with. And one big tip, and this probably won't make a lot of sense unless you try to download this data yourself, but in order to get that path function to work, you have to make sure that every predecessor run ID has a parent run ID. And if you bring in, it's possible to bring in a record that has a predecessor run ID that does not exist in your run ID columns, because it's just because of the nature of how we pull the logs, and when we limit the time range, you could end up with some orphan child pipelines. So the tip here is just to blank it out. And if any of you are interested in maybe a more deep dive on that, I could probably write a blog post or something to kind of explain what I did to do this and get this path function to work seamlessly. Okay, so after figuring out what my level 1 pipelines were, I was finally able to provide a closer monitoring tool to something that I could use to check like how I was doing. And I set this up so that it was, showing by day the duration of the parent pipeline, the level 1 pipeline. So going back to this graphic, I now had a way to discern what my level 1 pipeline was and what the timing was of the level 1 pipeline without knowing all the detail underneath it. So that helped me to get here. And it was extremely helpful to be able to see, oh, wow, on May 10th, it took double the time for this job to finish. What happened? What did we release? Did we release something, or was something colliding? That was another paradigm shift for us, is we figured out that we had jobs that were colliding with one another, using the same compute resources, starving our compute for resources when both pipelines were, or maybe multiple pipelines were trying to execute at the same time. I added some lines here to show me, okay, like we do have jobs that are like scheduled back to back. One's scheduled at 8, one's scheduled at 9, one's scheduled at 10. So I couldn't have the 8 o'clock take more than an hour. So that's what these lines were for. So that's the top level. And then here at the bottom level, I actually figured out through, looking at the data sets and everything, which of my pipelines were representative of each of the layers in my medallion architecture. So I went ahead and grouped them and called them just these simple terms so that I could, write a simple report like this so that I could see that, oh my gosh, like on the 16th, the reason this is so high is because of silver. Yes, it's attributed to a little bit in bronze, a little bit in raw, but silver is the culprit. There is something really, really wrong. There was something really wrong on silver on this day. What was it? So now I can go back into the ADF monitor, look at that job, and then try to figure out what happened, right? Big improvement to the monitor where I'm just looking at hundreds, if not thousands of rows of pipeline runs and have no idea what's what. The other thing this allowed me to start to do was separate the level 1 pipeline. So it helped me to start organizing these level 1s and understand like what priority to put on each one. So yeah, that was the start of that. And then we did have a 20-minute job that we, that was a lot, it's intended to have real-time information. It was intended to, be quick or feed one of our fact tables incrementally every 20 minutes. And again, the paradigm of collisions was something that we didn't know was happening until I put this together, and we figured out, oh wow, like there's a lot of times where our jobs take a lot more than 20 minutes. Like on the 15th here, I mean, you see, a lot of these jobs took over 40 minutes, over 50 minutes. And this box and whisker visual, very, very handy. It's a custom visual by Mac Software. It doesn't cost you anything, but it's a great tool to figure out distribution of if you have, something like what I had, which is all these pipeline runs and with varying times, to try to tell me, or, kind of gauge how well I am to that 20-minute threshold, right? And so this gave me something to work on. I had to try to figure out how to bring, or we as a team had to try to figure out how to bring all these box and whisker plots down underneath 20 minutes so that we're saying what we're actually doing, right? If our pipeline is supposed to run every 20 minutes, then all of these job runs should be underneath the 20-minute line, not not over the 60-minute line. And then I had a generic count appear of how many times the job ran per day. And so that way I could see, like, if there was a day where, twice it didn't run, again, out of all the noise, out of all the hundreds of thousands of records that I saw in the ADF monitor, this was just a simple way for me to visualize this so I could see, oh, what happened on the 13th? Why didn't two of the jobs happen? And then I could go into that, either, create another visual that's tied to this visual and cross filter, or maybe just go into the ADF monitor and take a look. In terms of failures, we had to understand what was failing. This is just a good example that we had failures every single day, and our user base could feel it, and our sponsor could feel it. So again, this was a way to discern, like, what in the heck is happening? What is failing? How many times is it failing? And it helps to draw our attention to what's the most important thing. In this case, we have this daily job. I can't look at these other names, but if let's say you're in marketing and you have an Amazon pipeline and you have an Instagram pipeline and a Facebook pipeline or whatever, depending on who you are or what the domain is, some of these other pipelines might be very, very important. And over time, we would start taking snapshots of this so that we could see, over time, there were some consecutive weeks where we'd see no failures, and I'd celebrate it. I'd send it to everybody and be like, yeah, guys, we have no failures the past 2 weeks. That's amazing, So anyway, this was all good. All good. We could distinguish the level 1 pipelines from each other. We could start looking at a little bit about performance. We realized that what collisions were happening when we didn't even know that those were occurring, and we could see these patterns. We could start to see, like, we were starting to get smarter about our orchestration. Like, it takes about an hour and 15 minutes to complete this, and we're starting to get underneath 20 minutes on our real-time data, but still there was more to be done. We didn't understand what data sources were slow, because, like, to what I was telling you earlier, I just taken the level 1 pipelines. I still needed to get to the deeper levels to understand what data sources were slow, what transformations were slow, how bad were our collisions. And again, we still had failures every day. So I needed more monitoring. And as luck would have it, I talked about this a little bit earlier. When you expand the nested JSON in those ADF pipeline runs, you uncover things. And one of the things you will uncover if you make use of these in your ADF pipelines is parameters. We had parameters for everything. Thank goodness. I think I hugged my data architect that day. So we had parameters for data sources. We had parameters for data sets. We had parameters for something we called ordinals, which was like the order of the data sources or order of the data sets by which we were either transforming them or loading them. And then we also had parameters for target tables, the end tables in gold, the dimensions and facts that our analysts, data scientists, and BI developers were all dependent upon. So once I uncovered those parameters, then I could get detailed information into what was happening in my raw layer, what was happening in my bronze layer, what was happening in my silver layer. And I can't tell you how many times this has been helpful for us when a pipeline is slow or something changed or yeah, I don't know. I can't think of all the times, but I was able to take a screenshot of this, draw a red box around, hey, why is this happening? And then we know which data source is slow. We know what day it happened, and we can go just right to that. And then it might be a code change, it might be something with the vendor, but at least we know where to go. And the incremental jobs, the visualizations got a little bit better. Now, this visual here, I owe to Jason Thomas, who's he works for Microsoft now. He has a great public Power BI report that shows different visuals for different things. And so I borrowed this one from him. It was a great way for me to look at our incremental jobs, how much were they on time and how many times were they overrun? We, would shoot for not, I would always shoot for as close to 100% on time as possible, but again, this is just for visibility, right? This heat map, I love heat maps. I do them in Excel all the time, and every 20 minutes, we should see our pipeline runs under 20 minutes. Through this visual, I figured out that we had a period of time where we did not have pipelines running for like a good 2 hours, which further told me that we were not doing what we said we were doing, which was we were running every 20 minutes. Well, not really. When I first set up this heat map, it was very apparent that we had 2 hours where we were not running the 20-minute job. So we improved that over time. We figured out the right clusters to put in place in Databricks and separate the resources so that we could run the incremental as close to 24/7 as we possibly could. There was one period or one job period where we had to restart the cluster. That was another finding of ours throughout this journey, was that restarting our compute helps to kind of flush it out of any memory or objects or whatever, and it really helped with the performance when we reset that cluster every single day. And here's that box and whisker plot, but now with the color coding for overruns and on time. Again, just getting smarter, getting wiser to try to understand what's going on and where we have problems. So now I felt like, okay, now I got something. Now with that third iteration of my monitor, I felt like I was behind. I was telling Mark at the beginning of this that the truck I just bought, I love it. I love the truck. But I have it always set here in the middle to my miles per gallon. And unfortunately, this is about what my truck does right now, is about 16 to 17, but I love it when it gets over 18 to 20. And I love to see that, right? In the same vein, I love to see when, all of these are like, most of these are in like 97%, or I love to see when this heat map is all white, or I love to see when this chart, all these bars are underneath that threshold. So I felt like I was sitting in my truck, but we still have problems. We still have problems that would creep in. We had new data that would come in that wasn't complete. We'd have data that wasn't formatted correctly. Data would be missing. Data ingest, we're not bringing in new data, and we wouldn't get notified. It was really strange, but some of you might attest to this, that sometimes your pipelines will run successfully. There's no failure, but there's no new data, right? What's happening? So enter in the 6 dimensions of data quality. Okay, you gotta be familiar with these when it comes to data quality or monitoring of your data systems. I think I have some examples here. Yeah. Well, before I get there, couple of these that are very important to us right now are completeness, so no missing of data. So maybe your data warehouse is about customers, right? And you get a new customer in, But when you get a new customer in, you have to know who's the sales representative. You got to know which region they're in. You got to have their complete contact information. You got to know this and you got to know that. Um, we have a situation very similar to that in our project now, and we have to know if the new data that's coming in is complete. So that's a use case for this SQL alert that I'm about to talk about in a minute, where we check that, and if the data is not complete, we get an email about it with like, what is it about the data that's incomplete? The other thing that we check is for timeliness, or we like to call it freshness, data freshness. Um, you know, every 20 minutes, are we getting the data for the past 20 minutes? Or is something wrong with the data source? If there's something wrong and we don't get data in the last 20 minutes, let's shoot an alert. Let's shoot an alert, because we should know, everybody needs to know, or maybe the right people need to know so that they can go chase it down. So these two things are really important to us, but you could probably argue in your case for any one of these six. But these six dimensions, very thorough way to look at data quality issues in your data systems. So we were sitting there saying, what are we missing? We need a way to be alerted about these things. We need a way to understand if our data has issues before our end users do. Okay. There was a lot of criteria that, as we looked at different tools that we were looking at to be able to, I mean, we wanted to do this quickly. We wanted to do this with as least tech debt as possible. And just something simple. We didn't need to develop a whole system. We had already done a QA framework, but really we weren't using it for this kind of thing. QA frameworks are really meant to kind of do a batch thing, like hundreds or maybe millions of checks in a single batch. What we needed is just every 20 minutes, we needed something that checks, did we get that data the last 20 minutes? So out of all these things we looked at, we ended up on Databricks with SQL alerts. Very simple objects to stand up in Databricks, where they're tied to a query. You can set a trigger condition. You can customize the alert notification, so you can add, more data or hints about what might be happening. And then you can also send this to emails or to a Teams channel or to some webhook that does other notifications or something in a different system. So what we do is we do Teams notifications and we do email. This is what an example email looks like. It gives you the ability to go to click, run the query that's behind the alert, so that you can see what's up, what's happening. And my challenge to any one of my engineers that works on these is to make this as useful as possible. Don't just tell me that something's wrong. Tell me what's wrong. Give me the enough information that I can be smart about where to go and what to do. And it's hard. This is kind of you got to really put your data quality thinking cap on, because you're trying to figure out what is the easiest, most straightforward content to put in one of these alerts. But they're super, super helpful. So I've talked for a lot. I'm nearing the end. There's this great read article that I read as I was getting ready for this talk, talking about data observability versus data monitoring. Really, the monitoring is the tip of the iceberg. I think what this article talks about that I really love is that observability comes when you're able to see trends, you're able to see patterns, you're able to provoke new ideas, new thoughts, new action plans to do things like improve your performance or make your system simpler, or do more with less resources, whatever it is. So I love this quote from the article. The pipeline may be operating fine, but the data flowing through it may be garbage. So, again, getting from, the pipelines are running fine to no, actually the data in them is also good is the holy grail, I feel like. I didn't know all of this when, I got asked this question over a year ago, but now my answer would be way different. So the holy grail of monitoring, it's really up to you. It's really up to you. I can't tell you what the holy grail of monitoring is for you. You have to be the designer in that, because I can't tell you, I don't know how your pipelines are set up. I don't know if you have child pipelines, parent pipelines like I had. But what I do know is that once you get started, once this is my story, right? Everybody's story is different. But I think once you understand your systems and what's important, that's where this you'll start to understand this, right? Like in a practical application like a car, looking at your gas gauge, how fast you're going, what the temperature is. You have monitor or indicator lights, whether you're in the lane or out of the lane. Do you have a low tire pressure? You know, um, that all of that is dependent up to you, because your data systems are your own, your business domains are your own, you have your own monitoring and alerts that you've got to develop for yourselves. But another thing that to be cognizant of is that data quality is a team sport. You can't do these on your own. Now, I don't envy people that might be their own architect, their own data engineer, their own analyst, and everything like that. And I know there's shops that have that. Um, so but it is in my case, it is a team sport. I've got 5 great guys, that 6 people that do a lot of the thinking with me, and they think of things that I didn't think of and create great like alert content, um, and even have ideas for or catch me on my monitor when things don't quite look right. Um, but get yourselves a good monitoring system. Go from like what I was just describing, from monitoring your system to really observing your system. Um, uh, like I said, good monitoring and alerting will provoke ideas. I can't tell you how many times I've stared at these reports, and it gives me ideas on how to time our pipelines better. What could we speed up? Um, and it also helped me understand what is normal. What is normal operation for us look like? And now I feel like more now than ever, we are constantly trying to be smarter about what we are alerted to, so that we know the issues, all the issues across all our data sets before the users do. And it in some cases, like I even tease some of the guys on my team. I'm like, your alert is my favorite. Your alert is my favorite. I love your alert. Your alert is so simple. It's so straight to the point. And just the other day, alert. So I go, I kind of I have fun with that. Um, and then lastly, all of this, share the good news and the bad news with the entire team, your team of BI analysts, data scientists, or whatever. Um, no news is not necessarily good news. Everybody kind of is guilty of this in one way, shape, or form, where, over time things just start humming along and everything's just hunky dory. And then you get a call like, hey, I don't see, this data anymore, or I don't see this customer. And then, oh, what's happening, right? Um, yeah, there's ways to work better than that, to be proactive and make sure that your data systems are up to speed and performing the best for your end users.